Okay, so alkynes on reduction with any platinum or palladium catalyst, you will get the direct compound, that is a alkane CH3, CH3. Okay, so why it is so means it is a strong reducing agent which can directly reduce the carbon triple bond to the carbon bond. Okay, so if you want to convert this alkyne to alkenes, okay, what is the possibility? What is the possibility? Okay, so that is called as stereoselective reduction of alkynes. Okay, here we are going to discuss. Okay, so what are those how you can selectively reduce alkynes to alkenes? Okay, in alkenes, you know these two types. There are two types of alkenes are there. Okay, so one is the cis alkene, another one is the trans alkene. How will you convert this alkyne to alkenes? Okay, so cis alkenes, how will you convert alkynes to trans alkenes? Okay, so one more good reagent is there, that is called as nickel boride. Okay, so why it is so means, so in the previous classes only we have discussed. Okay, so and one more catalyst I am going to tell. Okay, that is called as palladium. Okay, this palladium is a very strong reducing agent that will reduce the almost all triple bond to the single bond. In order to reduce the activity of the palladium, we are going to use calcium carbonate as a negative catalyst, or it is going to poisoning the palladium catalyst. Okay, so by this mechanism, the alkynes are reduced to the catalytic power of the palladium is reduced by the calcium carbonate. If you are going to use this catalyst, palladium or nickel boride, okay, so alkynes are converted to these Z alkenes. Why means, so the mechanism is so simple. Okay, so how the hydrogens they are going to add? Okay, previously we have discussed the syn addition of hydrogens from the catalyst surface. Okay, first what happens, the dissociation of the hydrogen bond is going to take place. Then these two hydrogens gets added to the C triple bond C in a syn manner, so that we will get the product C triple bond C, or sorry, C double bond C H. Okay, by this way it is possible to reduce the alkynes to the cis alkenes. Okay, so what is the another thing? So how you convert this alkynes to the alkenes? Okay, this is called as, okay, one of the reduction by using the group 1 elements such as sodium or lithium in the presence of liquid ammonia. If you are going to add this, okay, so the electrons are going to added in a anti-fashion, okay, so that an alkyne reduction takes place to then E alkenes, isn't it? Okay, so how will it happen? If you want to know mechanism, just I will explain here only. Okay, what is the starting material? R C triple bond R. Okay, what happens if you are going to use the sodium? Sodium is a highly reactive metal. Okay, in the presence of liquid ammonia, easily it will donate one of its electron to the alkynes. Okay, then what happens? It will convert it to the R C triple bond R orbital and the electron. Okay, so then what happens after the addition of this electron? Okay, so this bond is going to move here. Okay, carbon double bond, pi bond is going to move here. Then it leads to the formation of R C minus double bond C. Okay, so then what it makes? So which can easily abstract a proton from the liquid ammonia. So and it gets converted to the R C double bond. Okay, so then what happens? Again one more lithium or sodium atom which is going to donate its electrons to this one. Okay, and then you will get RCH double bond C and this one. Okay. Okay, then what happens? This, okay, now in this step, okay, so this carbon ion which can fix a proton from the anti-addition, which leads to the formation of RC double bond H. Okay, this is called as transalkene. By this way, it is possible to convert the alkyne to the transalkenes. Okay, the easier method is the sodium in presence of liquid ammonia. If you want to convert this alkyne to the cis alkene, okay, you can use the nickel boride, or you can use the palladium in presence of the calcium carbonate. So okay, so this is the method. Okay, so this is very important. Definitely they are going to ask in this paper. Okay, so and the palladium in presence of calcium carbonate is called as Lindlar catalyst. Lindlar catalyst. Okay, so this is the important thing. Okay, students, you please remember this one. Okay, so many disturbances there. Okay, so even though I just made this video for you, okay, so please watch this video. Okay, it is important, all kinds. Okay, in the examination point of view. Okay, only I have discussed the important thing. Okay, so okay, take care, bye, all the best.